Good morning and welcome back to Dr. Logic Awkwardly Does Logic. Let's talk about truth, and in particular, truth of modal statements, because we already understand how basic propositional logic is going to work. It's going to be exactly the same as it was before. But when we expand our horizons so that we're no longer talking about just what is true at one world, but what is true at many different worlds, we need to have an understanding of how to actually figure out what is true and what is not. Now, we have our frames, which are the sets of possible worlds and the ways they're related to each other. And we have our models, which is a frame plus information about which atoms are going to be true at which one of these possible worlds. So the next step is to build on top of that a recursive definition of truth that tells us how to determine for any type of formula, not just the atomic ones, whether or not they are true. So let me get my board up because we've got some definitions. Oh dear, I clicked something wrong. No, Zoom. There we go. A board. So we have already a notion of the valuation, and that tells us what's going to be true at any world in a model. We are going to expand upon that, but again, we're going to focus on truth at a world in a model. So definition, truth in a world, and what we have is as follows. So the truth of a well-formed formula in the modal language is always going to be evaluated at an individual world W in a model M. And this definition of truth, as I said, is going to be recursive. So we start off by saying, when is an atom true? So this is what we write. We say MW is a model of P, or that P is true at W in M, or MWV-P if you want to use the LaTeX word for the symbol. Many different ways, but just think of this as being truth at a world. Atoms are going to be true if and only if the valuation assigns to that atom at that world the value true. So if it's not, if the value of P at W is false, then P will not be true at W. Or another way to say it is that W is a model of P. Now, this is what we get just from the definition of our valuation function. What follows afterwards is building it up recursively. All of the propositional stuff is exactly what you would expect. If you have some complex formula phi, then its negation will be true at a world if and only if phi is not true at that world. A conjunction phi and psi will be true if phi is true at the world and psi is true at that world. A disjunction between phi and psi is going to be true if and only if one of the disjuncts is true. So what you can see is that what we've got here is just exactly the same as the truth conditions for propositional logic, rewritten in a different format than the truth tables, but it's just a notational variant. So with the conditional, we can express this by saying that either, sorry, that should be a phi there, either the antecedent is not true or the consequent is true. And you can see that this corresponds to the truth table for the conditional. So all of that is straightforward and easy. What's different is the modal operators. So when is it that some formula phi is going to be considered necessary with respect to a given world? That is going to be if there is nothing that gives this world any evidence that phi is false. So another way to think about this is that everywhere that W looks, so all of the worlds that are accessible to it, they all make phi true. So if you want to find a counterexample to say all cats are black, You have to just look around at all of the cats until you find one that isn't. And if you can't, then you conclude all cats are black. Similarly with necessity, except what we're doing is we're looking over all of the relevant possibilities. And if we can't find any one that makes phi false, well, then not only is it true, it's going to be necessarily true. So the way we write this out is we say that for all W prime, such that W sees W prime, or W prime is related to W, at that world, we have phi true. And then for possibility, it's going to be the same sort of thing. What makes phi possible with respect to W? It's if W can see at least one place where it's true. So it's not the case that everywhere it looks, it is false. So here we have the existential correlates. So there is a W prime such that W sees W prime and phi is true there. So immediately you can now see why modal logic is not truth functional. You can't just look at the truth values of the subformulas in order to determine what's going to be true at a particular world. You need to shift your attention so that you are looking at either all of the worlds that are related to where you are, or you can find at least one world that is related to where you are, which makes the formula true. So these two clauses are the fundamental basis for the non-truth functionality of modal logic. And there you have it. Here is truth in a Kripke model. Next time, we're going to talk about ways in which you can calculate the truth of a formula and also expand notion of truth to notion of validity in a model, on a frame, in a class of frames, and also just without any constraints whatsoever. So validity simpliciter. There's a whole bunch of things that we can do with these notions, but I will save that for next time to tell you exactly what they are. Take care and see you then. Cheers.